All right, in the last video we did long division of polynomial functions. This one we're going to take an easier route, I think, and do synthetic division, okay? Let's take a look at what a problem might look like. We've got this polynomial here, and we are going to divide it by x minus 4, okay? Just like on long division, this thing right here needs to be in descending order, and we can't have any missing spots. So it goes 3, 2, x to the first, and then x to the 0. Nothing's missing. If there is something missing, we just put a placeholder in it, okay? Now here's how this algorithm works. We're going to put a little box like this, and we want to make sure whatever we're dividing, if we're going to use synthetic division, whatever we're dividing by, it needs to have that it's binomial and a leading coefficient of 1. So there are ways around that, but I think for most of my students, if it doesn't have a 1 as that leading coefficient, then just make it, do it with long division there. All right, so go back to that binomial, x to the first, leading coefficient of 1 there. Here's what we're going to do. We're going to take whatever this is and take the opposite value of it, meaning if it's negative, make it a positive 4. If it were a positive 4, it'd be a negative 4 right here. Okay? The next thing we're going to do is look at the coefficients of this polynomial right here, and we're going to write them down next to it. So we got 2, -7, -8, and 16. All right, and then we're going to draw a little bar, not a little bar, but a bar going across, and I drop the first term, and I get a 2. And from here on out, the algorithm goes the same way all the way across. We multiply and add, multiply and add. So I'm going to say 4 times 2, that gives me 8. Add these two up. I get a 1. 4 times 1 is 4. Add these up. I get -4. 4 times -4 is -16. Add these up, I get a 0. And whatever is in this last column right here, that is what my remainder is. Okay? So my remainder is 0 here. And what does it mean when we have a remainder of 0? It means that whatever I divide it by goes evenly into that number. So that's what I've got here. I know that x minus 4 will divide into that. What does that mean? That means x minus 4 is a factor of 2x cubed minus 7x squared minus 8x plus 16. That's pretty cool. That's just dividing it out. Now, how many times did it actually go into it? Here's what we're going to do. We're going to say whatever this is right here, which is x cubed, we're going to go 1 degree less and write right here x squared, because 2 is 1 degree less than 3 there. And then I'm going to go x squared, x, and then x to the 0, which is just that. So we can say, we know for a fact that if you take x minus 4 times 2x squared plus 1x minus 4, if you were to multiply these two out, you're going to get what we originally had up here before we divided it by x minus 4. Okay? So that's what we got when we divided out. My actual answer, though, is this right here. That's what that mess is up top, divided by x minus 4. It equals what I boxed in right there. Okay? Try out another one. Let's go with this one. 2x squared plus 3 plus 5x, and I want you to divide it by x plus 1. So pause the video, give that a try. All right, I've taken it, you've paused it, given it a try. Let's take a look and see how to do it. 2x squared plus 3 plus 5x, that just doesn't seem right to me. And the reason why it doesn't is because it's not in descending order. Let's rewrite this so that it goes x squared, all right, 2x squared. The next term needs to be an x term here. Don't add 0x. We already have an x term there. It's 5x. And then the plus 3 goes right there. So we need to rearrange that so that everything is in the correct order. We can use synthetic division here easily because the leading coefficient is 1 on the divisor and it's raised to a power of 1. So I'm going to say, okay, take the opposite of positive 1, put a -1 there, put this little bracket thingy here, and then write down the coefficients. So we get 2, 5, and 3. Draw our long bar. And the first thing we do is to drop the first term and multiply. I get -2. Add these up. I get a 3 there. Multiply again. And when I add, I get a remainder of 0 again. All right, so I think for me, I like it when I get a remainder of nothing, but don't be bothered too much when you don't get a remainder of nothing. It happens all the time. So we're going to say we've got x squared term right here. We're going to go 1 degree less than x squared. We get an x, and then plus 3, and then plus 0. We don't have to write that out. Our answer is 2x plus 3. That means 2x plus 3 is a factor of the original, and so is x plus 1. Or you could say that this polynomial is going to factor into x plus 1 times 2x plus 3. These are just some things that we can get out of dividing these out and then getting a remainder of 0. All right, let's take a look at one more. Let me give you one that doesn't work out perfectly, because you know what? Life doesn't always work out perfectly, right? So I'm going to go with x to the 4th minus 10x squared minus 2x plus 4, and let's divide that by x plus 3. Give that one a try. Pause the video, try it out. Did you give it an honest attempt? If not, back it up and watch it again. If you did, let's see if you got it right, all right? So we've got this right here going on, and once again, something seems off because I have an x to the 4th, I have an x squared, but there's no x cubed in here. So we need to rewrite this so that we have 0x cubed somewhere in there. And then everything else is in descending order. So that looks good. We can use, once again, synthetic division easily here. I'm going to take the opposite of plus 3, put a minus 3 down and my bracket, and then I'm going to put those coefficients in order. So this is a coefficient of 1. Then don't forget the 0 goes in here. And then we've got negative 10, negative 2, and then positive 4 right there. Let's draw our bar. From there, we are going to drop the first term, and I get a 1 right there. Multiply, add, multiply, add, multiply, add, multiply. You're probably sick of me saying that now. And then add these up, and I get a 1 as my remainder. So remember that we're going to go 1 degree less when we write in these variables. So we're going to say this is, let's see here, 1 degree less can be x cubed, then x squared, then x, and then this is just the number 1 right there. So my answer is x cubed minus 3x squared minus x plus 1. My remainder is 1, and that goes over what I was dividing by, which is x plus 3. Don't forget to put a little plus symbol in here to say this isn't being multiplied, this is being plus 1 over x plus 3. Boom. Now, if you compare that to what we were doing earlier in the previous video with long division, imagine doing this here. Let's go back. Imagine doing this with long division. X plus 3, x to the 4th minus 10x squared minus 2x plus 4. And don't forget, we have to put a 0x to the cubed in there. X goes into that, x cubed times, and multiplying it out and subtracting, it can be pretty nasty compared to just this. This algorithm almost makes it systematic. So you're just like, flip the sign, drop it, multiply, add, multiply, add, multiply, add. Not a whole lot of thinking needs to go on there, but please be careful when you're doing it. It is easy to make a mistake if you don't think at all. I do it a couple of times every year. I say 3 times -1 is -1, and I'm completely wrong. But it's easy to get into that rhythm and kind of go on autopilot and not multiply out something simple there, okay? So give the homework a try. Hopefully this makes dividing polynomials a little bit easier for you. And if you have questions, let me know, and I'll see you next time.